So today we are going to talk about the quadratic formula. In general, kids don't like the quadratic formula. There's a lot of room for making mistakes. And so even though it's not necessarily hard, you have to be careful and make sure you're especially keeping track. So we've looked at finding solutions. Remember, solutions, roots, and zeros are all your x-intercepts. We've used graphing just by looking at the graph. That one's pretty easy to identify where it's crossing the x-axis. Then we did by factoring. But the problem is sometimes you can't use factoring. Sometimes you can't factor an equation. And that's where the quadratic formula comes. Here, x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a is the quadratic formula. I wish I had a formula sheet in front of me. I believe this is on, not that you're taking the SOL, but I believe this is on the SOL formula sheet. But we need to figure out how to use it. All right, so this is an example. I want to talk about discriminant first. A little bit more in like Algebra 2. I don't teach Algebra 2, but that is my assumption. The discriminant is b squared minus 4ac. It's this underneath your radical. And what this does is it gives you a couple of important pieces of information. If you calculate this, and you discover that it's greater than 0, it means that there are two real solutions. In Algebra 1, we only talk about real solutions. If it's equal to 0, it means that there's one real solution. And if it's less than 0, it means there are 0 real solutions. And although we won't necessarily use this in this class, I do think that this is important information, and you will use it at some time. All right, so I'm going to go ahead and jump down to the examples down here. All right, we have an equation, x squared minus 12a plus 20 is equal to 0. We're going to identify our pieces. We have talked for several days that this is the form of your quadratic equation, ax squared plus bx plus c equals 0. And so we need to identify those a, b, and c. Those are the coefficients squared of your x and then your linear term c. Making sure you keep track of your signs. So in front of our x squared here, we have a 1. In front of our x, which is our b term, we've got a negative 12. That negative belongs to the 12. Any sign in front of or to the left of a number belongs to that number. And then our c term is and then we get to fill in our equation, and it's big, it gets kind of messy. You got to be real careful to keep track of your signs. I think what I'm going to do is I'm going to write it right here so that we can refer to it. X equals negative b plus or minus the square root of b squared minus 4ac all divided by. We're just going to substitute it in. Negative b. The formula, the quadratic formula, has a negative on it. So in this case, when our b is also negative, you end up with two negatives. So negative 12. Two negatives become a positive. So 12 plus or minus the square root of b squared, parentheses. If you don't put that negative 12 in parentheses, 90% of the time, what's going to happen is you're going to end up with a negative number under your square root. And then when you try to take the square root, you're going to get an error on your calculator and you're going to be like, I don't understand. You missed a negative. I mean, a parenthesis around a negative. So we've got negative b squared, negative 12 squared, minus 4, because that's in our formula, times a, which is 1, times c, which is 20. This whole thing over 2 times a. A here is 1. Be careful. The other thing people like to do is cut their square root early. So they'll do like 144, and then they'll have the square root of 144, which is this negative 12 squared, and then they'll do minus 1 minus 20. This whole thing is underneath the radical sign. So we've got 12 plus or minus squared is 144. And then 4 times 1 times 20, we get negative 80. On the bottom, 2 times 1 is 2. Keep going under our radicals. 12 plus or minus the square root of 144 minus 80 is 64, all divided by 2. And then the square root of 64 is 8, so we get divided by 2. And now we're going to talk about the plus or minus. We need to do both ultimately. So we're going to say 12 plus 8 divided by 2. And over here, we're going to do 12 minus 8 divided by 2. So 12 plus 8 is 20, divided by 2 is 10. And then 12 minus 8 divided by 2 is 2. So our answers are 10 and 2. And you can always check yourself. It's not, let's see, I'm working on my calculator here as I talk. It's not always going to be super easy because a lot of times you're going to, when you're using your quadratic formula, but you can still kind of estimate to see if you figured it correctly. So I graphed x squared minus 12x plus 20, and I'm using my calculator. You can also use Desmos, and I'm going to slide over. And this calculator does not like to give absolute exact answers, which I can't stand, but our x is 2. This one goes off the screen just a little bit, but you can see that the x-intercept is 10 and 2. And that's what we found, that the solutions are 10 or 2. Solutions, roots, zeros, x-intercepts, all the same thing. All right, so I know that was a lot of information. Let's try just hitting the math again. 2x squared minus 3x minus 65. My a this time is 2. My b is negative 3. And my c is negative 6. And then I'm going to plug everything into my formula. Negative b. B is negative 3, so I do have those two negatives again. Plus or minus the square root. Make a long square root sign to make sure you remember that this whole piece goes underneath. B squared. Negative again, make sure you have parentheses. Negative 3 squared. Minus 4. A this time is 2, times C, which is negative 65. Oops. And then that is all over 2A. A this time is 2. And then we're going to go ahead and hit some of our math. Negative, negative on our 3 gives us a positive 3. So positive 3 plus or minus, you use parentheses, is positive 9. Negative 4 times 2 times negative 65 gives us a positive 520. And then that's all over 2 times 2, which is 4. Three plus or minus 9 plus 520 is 529. The square root of 529 is 23. And we are still over 4. And then at this point, we're going to break up into our plus and our minus. So 3 plus 23 divided by 4. So 26 divided by 4. You're going to start to get decimals. Is that it's used to factor things that aren't factorable. Which usually means that we're dealing with decimals. I'm going to leave everything in fraction because that's the better mathematical answer, but you need to have your fractions reduced. So 26 fourths gives us 13 over 2. So that's our first x-intercept. And then 3 minus, which is negative 20 divided by 4, which is negative 5. So our x-intercepts, our solutions to this problem are 13 over 2 and negative 5. Number 3, we have 4x squared minus 24x plus. Write our formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Identifying my a, b, and c. My a here, is 4. My b is negative 24. And my c is 35. And then let's negative b. Again, we have a negative b, so we're going to have 2 negatives there. Plus or minus b squared, parentheses, you need them, minus 4 times a times c. So 4 times 4 times 35. All divided by 2a. Our math. So negative negative gives me a positive 24 plus or minus negative 24 squared is 576. 4 times 4 times 35 gives us a 560. 2 times 4 is 8. Minus 576 minus 560 gives us a square root of 16. Then the square root of 16 is 4 over 8. And now I'm going to break it up. So we get, what do we get? Oh, 24 plus 4 divided by 8, which gives us 20, which dividing by 4 to reduce, we get 7 halves. So that's our first intercept. And then we're going to do the subtraction. 24 minus 4 divided by 8. 20 divided by 8 reduces to 5/7. Number 4, we've got 3x squared minus 11x minus 70. All right, so a little bit different here. You notice we are not set equal to 0. We need to be set equal to 0. So we need to move that 70 over to the left, and we're going to do that by subtracting. So where do I write? I'm going to write this above. We end up with 3x minus 70 is equal to 0. Now we can use our A, B, and C. Please don't tell me that C is 70. C is not 70, it is negative 70. Our A is 3, our B is 11. Anytime the B is positive, it's a little bit easier to make sure you're getting the right answers. C is negative 70. All right, X equals, so negative 11 plus or minus the square root, B squared is 11, so 11 squared, minus 4 times A times C. So 4 times 3 times negative 70. All over 2 times. All right, negative 11 plus or minus the square root of 121 plus 840. Couple things. This is, even though our B is positive, which makes it a little bit easier to deal with. If you had told me that C was 70, you would end up with a negative here. So you'd have 121 minus 800, a negative number underneath your square root, which was going to scream error to you on your calculator. So anytime you're getting error on your calculator, you're missing a sign somewhere. Go back and re-look at your signs. And then 2 times 3 is 6. Negative 11 plus or minus, when we add those, we get 906. The square root of 961 is 31. And then I'm going to break it up and do my plus side. So negative 11 plus 31 over 6, which gives me 21 over 6, reducing down to 10/3. All right, this is a 20. That solves our problem. So now our answer is 10/3. And then we're going to do the minus side. Minus 31 divided by 6. So negative 42 divided by 6. So our second is negative 7. Number 5 is set equal to 0, so we can just pull in 15. X equals negative b plus or minus the square root of b squared minus 4 times a times c. Make sure all of that is under your square root, all divided by 2 times a. Underneath, 121 minus 120, all divided by 2 times 2, which is 4. negative 11 plus or minus the square root of 1 divided by 4. Square root of 1 is just 1, so negative 11 plus or minus 1 divided by 4. And then we break it up to plus side, minus side. Negative 10 divided by 4, which simplifies, the more room I have, the bigger I write. Simplifies to negative 5 halves. And then negative 11 minus 1 divided by 4. Negative 12 divided by 4 is negative 3. So we get negative 5 halves and negative 3. And finally, number 6, we are not set equal to 0, so we need to move that 5 over, which gives us x squared plus 8x plus 5. My A is 1, my B is 8, my C is 5. 1, 8, 5. X squared equals negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. Negative 8 plus or minus the square root of 8 squared is 64, minus 4 times 5 times 1, which is negative 20, divided by 2. Negative 8 plus or minus the square root of 44. Oh, okay. Divided by 2. Even less. Square root of 44 is not it's not a perfect square, but good mathematicians, we need to reduce or simplify our radical. So I'm going to come over here and we're going to look at the square root of 144. And we're going to go back a unit or two and make a factor tree. And I'm going to say 44 can be broken down into 4 times 11. Can be broken down into 2 times 2. And I'm looking for pairs because we have a square root, so I've got a pair of 2's, which means I can reduce the square root of 44 to 2 times the square root of 11. So I'm going to come back over here and I'm going to say negative 8 plus or minus 2 times the square root of 11, all divided by 2. Because we have a radical still in our answer, we leave it like this, except that if we have places we can reduce here, we need to do that. And this is where we would kind of break it down. I want to break it down a little bit more before I go on. So we could do plus or minus 2 square root of 11 divided by 2. And then we need to reduce anywhere we can. Well, negative 8 divided by 2 is negative 4. On this side, 2 divided by 2 goes away and we have just the square root of 11. So plus or minus the square root of 11. And this is how you're typically going to see your final answer, the square root of 11. If we get pieces of our answer that are still in radicals, we leave them like that, and we leave it as one piece with the plus or the minus. And that is the quadratic formula.